My brother-in-law asked me to take a look at this Delco radio. It's a basic model, AM only, with the tuner here, volume here, and tone control. The symptoms prompting repair were that it didn't light up or make any sound, and that it wasn't found when attempting to pair via Bluetooth. The lamp was easy to diagnose. It's burned out. As for the rest, I started by removing the covers and using my eyes and nose to check things out. I didn't notice any obvious reason for the malfunction, so I connected a bench supply and slowly dialed up the current limit. Right off, I could see that it wasn't drawing any current at all, so I suspected an open circuit. I checked the voltage at the input. It was good. At the output of the power switch, though, there was no voltage. Since it felt good mechanically, I suspected the contacts might be oxidized. So I bypassed the power switch with a jumper and slowly dialed up the current limit again. It came up and stabilized without any sparks or smoke, which I took as a good sign. Twisting the volume knob gave static through the speaker, so it seemed that the audio frequency section was more or less working. A spin of the tuning dial didn't bring in any stations, but the client would like Bluetooth, not AM reception, so I haven't diagnosed the RF section any further. Let's take a look at the schematic. I don't think it goes with this exact radio, but it's from a similar model. As advertised, this radio has 5 transistors and 2 diodes. Wow! We can see right away the trouble with the Bluetooth. Of course, this radio from 1964 doesn't have it. These 3 stages on the left are the RF section, and the 2 on the right, the AF section. Conveniently, the circuit can be split here at node 18. I lifted the wire that connects the volume control here to the circuit board. An audio signal applied here will be amplified and reproduced at the speaker output. I determined the appropriate input signal level empirically rather than by calculation. I connected a load to the speaker output along with an oscilloscope and applied a sine wave to the input. With the volume control at maximum, I increased the input signal until I could see distortion in the output, then backed off a bit. This gave a maximum input level of 80 millivolts peak to peak. Since that's much less than standard line level, a passive attenuator is all that's needed to adapt a standard Bluetooth module. Well, almost. Perhaps you've noticed something about this car stereo. 1 power transistor, 1 speaker terminal. It's not a stereo at all, it's monophonic. So we'll need to mix the stereo output of the Bluetooth module down to mono. A simple way to do this and provide the needed attenuation is with 3 resistors. If A is much larger than B and B is much less than L, then the input impedance is about A and the output impedance is about B, well, the attenuation is approximately the ratio of B to the total of A and B. The input is assumed to be line level or minus 10 dBV. The output should be around 80 millivolts peak to peak, which is 28 millivolts RMS or minus 31 dBV. So we need about 21 dB of attenuation. Well, keep in mind that we're combining 2 channels, so the input could effectively be 6 dB higher. With values of 22K for A and 1.8K for B, we get reasonable input and output impedances and an attenuation of about 23 dB, which is right in the ballpark. Now, a capacitor on the output blocks bias voltage from the first audio frequency stage. The impedance of this capacitor should be low with respect to the output impedance of the attenuator at the lowest frequency of interest. Now, this isn't exactly a hi-fi set, so we'll go with 100 Hz and a target of 180 ohms. A standard 10 microfarad cap is satisfactory. I don't think a Bluetooth module would work well from inside this tin can of an enclosure, though there are some apertures large enough that it might have. I decided to add an 1/8 inch jack to the bottom of the case so that the module could be connected externally. It also leaves the possibility of connecting other line level devices. Since this is just a one-off, I assembled the circuit on a piece of perf board and mounted it to the back of the new jack. Some contact cleaner fixed the power switch and cleaned up the scratchiness in the volume and tone controls. Testing shows that this radio has been brought successfully into the future without modifying its appearance or vintage sound. Hope you enjoyed this video. If so, please give it a big thumbs up, and if this is the kind of thing you're into, hit that subscribe button.